Okay, in section 1, we're going to be going over numbers. So it's really straightforward here. This video and the next one should be relatively small. All right, but what we're going to look at here is we're going to look at the following. We're going to look at the real number system. Then we're going to look at the number line itself, followed by the absolute value, signs of inequality, reciprocals, denominant numbers, and finally, literal numbers. All right, so that's what this video is going to cover. So let's first focus on the real number system. Now, a lot of this is going to be things that I think you already know. It's just maybe it was never presented to you like this, or maybe nobody ever asked you these questions before. So first, the real number system is made up of different sets of numbers. So real quick, even though this is not in your textbook, I'm going to define what a set is, or sets. Sets are objects with a common characteristic. All right. So in math, a set would be like, or a famous set is 0, 2, 4, 6. And it just keeps going. And hopefully you recognize that these are positive, even numbers. Okay, so what do they all have in common? Each number oops, sorry. Let me just write this real quick and then I'll explain it. So what is common? Each number is even. And how do we get even numbers? Well, we just take 2 and we multiply it by any other number we want. So like 2 times 0, 0. 2 times 1, 2. 2 times 2, 4. 2 times 3, 6, and so forth. Okay? So this is how we actually generate our real number system. So the first numbers that you actually learn, and this was a long time ago, were natural numbers. Now this is a set, and what's common with this set is natural numbers start at 1, and they go 1, 2, 3, 4, and so forth. The next set that you learned about were whole numbers. Now, what makes whole numbers different from counting numbers? Whole numbers start at 0, and then they go positive, all right? So that's that new thing within the whole numbers, all right? That number 0. Next are going to be our integers. Okay? Now, you've seen integers before. Integers are positive and negative whole numbers. All right? So, if you kind of look at this here, and I'm going to use a highlighter here. If you look at what we have on the board here, you can kind of see some things happening, okay? As time progressed, we've started to introduce more numbers. All right? So like, for example, the natural numbers 1, 2, 3. Whole numbers, somebody had to come around and say, okay, there's this number called 0. So they included it, but now it's a brand new set. Then somebody else came along and said, well, what about negative? What about the other side, okay, of 0? And so forth. So the last two we're going to go over are rational numbers. Now, you know these. They're simply fractions. So they look like this. So they're going to be A over B, where A and B are integers. And this is huge, B is not allowed to equal 0. So that's what a rational number is, okay? Now, can rational numbers be decimals? All right. Can rational numbers be decimals? And think about that. Answer it in your brain. All right? Or pause the video, answer it, then come back. But the answer is yes. Remember, a rational number can be written as a fraction. So, 1/3, although its decimal representation is 0.3 repeating, is a rational number because it can be written as 1/3. So, rational numbers can be decimals. But then the question becomes, what if you have a non-repeating decimal? Well, that's our last group. And those are called irrational numbers. Okay? And irrational numbers, quite simply, the way we define them, they cannot be written in the form of a fraction. So the most famous, pi. All right? Another one, e. Another one, the square root of 2, and so forth. So the next thing we got to worry about is, what do we do with all of these numbers, okay? Well, when you combine all these numbers together, okay, let me go back, let me zoom out here so we can see everything. So when we combine the natural, whole, integers, rational, irrational, when we combine all these numbers together, we've just created what we call the real number system. So all of these numbers make up the real number system. And to kind of keep this simple, the real number system is basically any number you can plot on a number line. Okay? It's any number you can put on a number line. So a natural question would be, are there other types of numbers that exist? Because like I said, the real number system is everything. It's all the numbers you know. So, big question is, are there any other type of numbers? And the answer is absolutely. For example, if I asked you what the square root of 4 is, you would say 2. But what if I asked you, what is the square root of -4? Well, the square root of -4, which you might have seen already, we'll probably go over this later in the semester. But the answer is 2i. And this, 2i, is what we call a complex number, all right? It is imaginary, all right? So if you want to kind of think of it in terms of a picture, here's what we have. This rectangle is going to represent the universe. It's everything that you know. Within this universe, you have your natural numbers. You have your whole numbers. Try to draw this as best I can. You have your integers. Oops, misspelled that. You have your integers. You have your rational. Let me try to do this a little nicer here. I'm writing down here. You have your rational numbers. All right. Then over here, in its own little circle, you have your irrational numbers. All right. And all of these, like I said, are your real numbers. They all make up the real numbers. Okay? However, over here to the right are those complex imaginary numbers. So they're like doing math on two different planets, if you want to think of it that way. All right? Now, we just went over the real number system, so let's talk about this number line. Number line is pretty easy. I'm not going to give you a 15, 20-minute lecture on a number line. Number lines start at 0 in the middle, which is called the origin. Positive numbers to the right. Negative numbers to the left. Now, what about this thing called the absolute value? Okay? A lot of us, we've seen the absolute value, such as the absolute value of 3 equals 3, and the absolute value of negative 3 also equals 3. But the big question is, why? And the answer is not that the absolute value is always positive. The absolute value is a measurement of distance. All right? That's what the absolute value does, is it measures distance for us. So, how can I demonstrate this? Well, we're going to go back to our number line. Here we go, nice and neat. And the absolute value of 3, remember, is a distance away from 0. So if you think about it, right here, that is the absolute value of 3, because it's a distance away. But on the other side, this is also a distance of 3. It just, that negative symbol just means you moved in the opposite direction of what we deemed positive. That's all it means. Remember, a long time ago, you were taught that if there's a sign in front of the number like a negative, all right, that just means the opposite of. So the next thing we're going to go over is the signs of inequality. I forget what we are. 3, 4. Okay, good. So signs of inequality. Now, the signs are nice. I'm pretty sure if I asked everybody here, you know, what are the signs? You would nail them. But the question becomes, why do we use inequality signs? Well, inequality signs are used to compare values or expressions. All right? So like, for example, form a true statement using inequality symbols less than, less than or greater than. And the example is 5 and 20. Well, if you want to form a true statement, remember, we always read inequalities always from left to right. I know you can read them right to left, but to keep everything nice and consistent, we're going to read them from left to right. So the inequality symbol here I would use is less than. All right? And just so we can review, we have less than, greater than, less than or equal to, and greater than or equal to. Okay? Now, what's this thing about reciprocals? Because remember, this is just a review of the first section. So that's 4. Okay, so here's 5. All right. So every number except 0, you got to exclude that one, has a reciprocal. All right. And all it means is to invert or flip the number. All right, so some examples. 2 over 3, its reciprocal. I'm just going to abbreviate it as recip. Its reciprocal is 3 over 2. Even the number -4 or 5, we'll go with -5. Even the number -5 is really -5 over 1. So its reciprocal would be -1 over 5. The reciprocal flips the number. It does not change the sign. All right? Now, the last 2 things we're going to go over, which are probably new things, but you already know what they are. All right? It's just maybe you didn't know they had a name. So in applications, when we have numbers that represent a measurement, all right, and include units. Units are huge. So in applications, numbers that represent a measurement and include units are called denominant numbers. All right. So for example, let's say you were measuring the diameter of a tree. And you found the diameter to be 24 inches. This is a denominant number because it's a measurement and it contains units. All right. Another one would be like speed of a car. Let's use a better word, velocity. All right. Normally, if you're driving on the parkway or something like that, speed limit 55 miles per 1 hour. All right, so you have a measurement and you have its units, denominant numbers. All right. Sometimes it's usually more convenient to state the definitions and operations on numbers. This is what we mean by literal form or literal numbers. And this will be the last thing we go over. So sometimes it is more convenient to state definitions and operations on numbers in general form. This is called literal numbers. All right. So I guess in a very simplistic way, we could think of this as formulas. So like we have Ohm's law. what is that? I equals voltage. So current equals voltage divided by resistance, Ohm's law. All right. We even have like something like a squared plus b squared equals c squared. That's Pythagorean theorem. All right. You can even have p of x equals r of x minus c of x, which is our profit function. Where p equals profit, r of x is our revenue, so it'll be our revenue function, and c of x is our cost function. All right. And that is going to be pretty much it for this first section. It's very straightforward. It's just a review of kind of everything you know about numbers.